Electrical stimulation. The brain can be stimulated electrically to gain information about the working of its various neural systems. When the brain is stimulated, there is a change in the resting membrane potential and an action potential is initiated. This causes behavioral changes depending upon which part of the area has been stimulated. For stimulating the brain electrically, electrodes are used. Microelectrodes are made of fine metal wires through which the nerves are electrically stimulated. Macroelectrodes are made of steel wires and are placed either on top of the scalp or inside the brain to record the functioning of the tracts, which are a large number of neurons together. The electrical recordings can be made over a long period of time, such as when the animal is recovering from any surgery. This is known as chronic recording. If the scientist is focusing to study a particular nerve pathway or where the information is going, then acute recording is done. These recordings of the electrical signals are then displayed through an oscilloscope or ink writing oscilloscope. It helps to display the electrical recordings per unit time. It has a cathode ray tube on which the display is done. It is used to record the activity of one single neuron. When the action is detected, it is amplified and easily heard by the researcher. To put it simply, an oscilloscope is a sophisticated diagnostic instrument that draws a graph of an electrical signal. Let's see oscilloscope in next slide. So this is how it looks and its basic features and functions. Ink writing oscilloscope. This is also known as polygraph. The evoked potentials are recorded with the help of various electrodes that are attached to the scalp. There are needles or pen tips that record the neural activity on a rolling paper with ink. When the signal is detected, it is amplified and pens move up and down, writing the action in ink on a continuously rolling paper. These recordings of the brain are known as electroencephalogram or EEG. These help to detect any tumor in the brain, epilepsy, or study sleep or arousal patterns. Modern techniques use computer to record the information and display it on the screen. The attached computer helps to display, store, and analyze the information that is collected by recording the electrical signals. So this is how an ink writing oscilloscope or polygraph looks. Chemical stimulation. There are various ways to chemically stimulate the brain and make lesions. Drugs can be given by injections or by inserting a tube into the stomach directly or into a vein or fatty tissue in the body. The chemical activity of the brain can be accessed by using various techniques. One is by using 2-deoxyglucose technique or 2DG. 2DG is a radioactive drug, and when this drug is injected in the animal, the researcher waits till it is absorbed by the brain. Thereafter, the animal is killed and the brain is removed and slices are made. Autoradiography is conducted, that is, the slices are coated with photographic emulsion. These are then developed as a film. Neurons that have taken the drug appear like black spots on the slide. Another useful technique is cerebral dialysis. A tube is inserted into the animal's brain. The animal is then engaged in an activity and the neurochemicals released while the animal is active are collected and analyzed using a chromatograph, which is depicted in the screen in front of you. In vivo voltammetry. In vivo voltammetry is another technique that is used to record the neurochemicals released in an animal when they are actively involved in some activity. Immunocytochemistry is a process which helps to locate the presence of neuroproteins in the brain. Each neurotransmitter responds to its specific receptor during the synapse. Microiontophoresis is a process that involves injection of charged molecules used to apply drugs or chemicals to nerve cells. It helps to locate the specific receptors to which the neurotransmitters respond. Stereotaxic lesion. When ablation is not possible for tiny structures located below the surface of the brain, researchers use stereotaxic techniques to damage a structure in the interior of the brain. First and foremost, it is important to identify which part of the brain needs to be investigated. The stereotaxic atlas helps to locate the exact point of the brain where the surgery has to be done. Once this is done, the animal's head is placed in the head holder of the stereotaxic apparatus, which we will see in the next slide. Once the head is firmly held in the apparatus, the electrode holder is used to insert the electrode or cannula into the brain. The electrode can be implanted permanently, and when the animal comes out of the effect of anesthesia, behavior is monitored. When the study is over, the animal is given anesthesia again, the electrode is removed, and the animal recovers from it. This is stereotaxic apparatus.